Okay, so we've got a sample of a population here, and it's split up into this little table here where each variable is listed with each observation on the rows. So this would indicate observations. So this is the observation for this corresponding variable. So at the top here, these are the variables. So our goal in this question is to find the sample covariance of y2 and y4. So that would be this one and this one. So number 1 and number 3 variable we're not going to need for this question at all. So sample covariance, this is not population covariance, it's sample covariance. So I've written the formula down here. So S stands for the sample covariance of A and B. Well, in this case, A would be 2 and B would be 4. So we'll let A equal 2 and B equals 4. So that will break that down. N is just a number of variables. So N in this case would be, N would be the number of observations. And the observations is 1, 2, 3, 4, 5, 6. So N equals 6. And here we've got 1 over N minus 1. So that's going to become 1 over 5. And then it's the summation of, it looks like standard deviation of each multiplied together. So YA1, that will be the corresponding observation per each variable, subtracted from the mean. So this line above will be the mean. So Y bar means the mean of this. So that's in this case Y2. So in this case Y2. Multiplied by with YBI. So that's every observation in this column here. Subtracted from the mean of this variable. So in this case B is 4. So it'll be the mean of this variable here. And then we're just going to sum them up for each observation. So we're going to go through that now. So first thing of all, we need to find the mean for each one of these columns. So the variable y2, so y2, so the mean of that, let's calculate what that is, and the mean of the variable y4. So we'll add all these up. So we get 394, 596, 796, 831, 1045, 1145, 1230. So that's 1230. And then we need to divide that by 6 because it's 6 observations. So dividing that by 6, we get 205. Then we add all these up, 19, 31, 42, 77, 89, 96. So that comes to 96. Divide that by 6, that's just going to be 16. So now we've got the value of this and this already. Okay, let's write this down in a little bit more concise language relevant to this question. So sample covariance of A and B, that's 2 and 4. So sample covariance of 2 and 4, put a comma in there so it doesn't look like 24. And that equals 1 over n minus 1. Well, n is 6, so we're just going to put a 5 in there. And then we're going to sum them up for all of the observations. So that's 1 to 6, so n is 6. And then YAI, so that's going to be Y2 I minus Y bar A, so that's Y bar 2, so mean of the second Y2 variables, second column. And then YBI, that's just the Y2 I's, sorry, the Y4 I's, minus the mean of column 4, so that's the Y4's. Okay, now what we've got to do now is simply just write them all out. So we've got 1/5 multiplied by the sum. So put a big bracket there. Okay, now we know that this value here is 205. And we know that this value here, Y4, is 16. So we just bear that in mind as we're going along. So the first one, first observation, is 185 in the second column. So we're dealing in this column here and this column here. So 185 minus its mean, that's 205, and then multiplied by first observation in this one, which is 19, minus its mean, which is 16. And then simply we just go down the line and just put them all in. So 214 minus 205 times 12 minus 16. Third observation is 235 minus 205 times 11 minus 16. And then we're going to add on to that the fourth line, which is 202 minus 205 times 35 minus 16. And then we're just going to add on to that the last two lines, 194 minus 205 multiplied by 12 minus 16. And then we're going to add on another one, the last one, which is 200 minus 205 and 7 minus 16. Okay, that's just a pretty straightforward case now of just trying to do the algebra on all this and get all our mental arithmetic right. So 1 over 5, so 185 minus 205, that's minus 20. 19 minus 16 is 3, so that's that one. 214 minus 205 is 9. Multiply by that by minus 4. 235 minus 205 is 30. And multiply that by 11 minus 16, which is minus 5. 202 minus 205, that's minus 3. 35 minus 16, that's 19. And then 194 minus 205, that's minus 11. 12 minus 16 is minus 4. And then the last one, minus 5, minus 9. Okay, so now what's quite important when we're looking for the sample covariance is whether it's positive or negative. So we're going to make a little assumption here. So we've got a negative, 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 positive and positive. So we've got 4 negative values and 4 positive values. So what we're hoping for, or what could be the case, is if these positive values are really large and these are small, we could end up with a positive sample covariance. And if these are quite small compared to the total of all these, we can end up with a negative sample covariance. So let's just do the sums on this now. Let's do our mental arithmetic. 1/5 times minus 20 times 3, that's minus 60. 9 times minus 4 is minus 36. 30 times minus 5 is minus 150. 3 19s minus 57. Minus 11 minus 4 plus 44. And minus 5 times minus 9 plus 45. So this is looking like it's going to be a negative covariance. So then we've got minus 60 minus 36 is minus 96. Minus 150 is minus 246. Minus 246 minus 57 is minus 303. And then add on 44 and 49, which is 89. So minus 303 plus 89 is minus 214. So that's minus 214 over 5. So therefore our sample covariance of that is going to be minus 42.8. So that's a negative sample covariance. So what does that mean when it's negative? Well, we can have a negative sample covariance, that's fine. But what it means is we've got alternating values. So when the Y2 is low, the Y4 might be high, and vice versa. So, for example, here, the mean of these is 205. So this is below and this is above. So this one's mean is 16, you see, so that one's above. So we've probably got a lot of that going on rather than them all being of the same size. So for example, all the minus signs, they're going to be examples of when we've got a high and a low point. And the plus signs, they're going to be examples of when they are both of the same size. So look at this one here. This is a good example. This is below the average and this is below average. Same with here. This is below average and this is below average. Hence how we get a positive value for the sample covariance. But the weight of the negatives far outweighs the weight of the positives. So hence why we end up with sample covariance of minus 42.8. Okay.